Hello everybody, my name is Jose, and today I will be explaining the concept of RMS values and where they fit in physics. To start off, I will explain the difference between direct current and alternating current. So direct current is the steady electrical flow of charge in one direction, and alternating current is the flow of electric charge that periodically reverses direction in a sinusoidal pattern. So now we will look at some graphs of the voltage and current within each of these, a sample circuit of a direct current and alternating current. So first, in the direct current, so we can see that the current, as time passes, the current stays the same, as well as the voltage stays the exact same the entire time. But with an alternating current, we can see that it periodically goes to a maximum, which I've labeled as V0 and I0 for the respective voltage max and current max. And we see it goes to a maximum, and then it goes down to a minimum, then back to a maximum, and it will do this the entire time it has the flow of electric charge. And so what it's important to notice from the alternating current graph is that the voltage and current values in this particular example that I'm explaining are in phase, and you must also remember that it is a constant fluctuation, right? Of max and going back down, max, go down. And that's how the alternating current works. Okay, so when we look at an alternating current voltage source, this kind of helps to get my point across. It's still the same, and it has a voltage max positive, voltage minimum. The potential difference, or V, between terminals of an alternating current circuit. Okay, so the potential difference V between terminals of AC voltage source fluctuate, right? So that potential difference of V is fluctuating between the terminals of an AC voltage source. So I'll have a little cartoon that kind of will help explain this. Here it's going in the counterclockwise direction. Here's that same circuit again, same simple circuit, still with an alternating current, and now it's switched directions. And so it's constantly doing this. It's constantly fluctuating between going one way, going the other way, and so that potential difference between those terminals fluctuates. This is represented by a mathematical expression of V0 sine 2 pi times frequency times time equals the voltage at a certain time. And this expression is just used to represent kind of what we see in the graph, and it makes it possible to calculate a certain voltage at any time if we know the voltage max and the frequency. We know that current equals voltage divided by resistance, right? And so why is this important? Well, that means that we can use a similar equation for current, right? So current at any particular time is equal to the maximum value of current times the sine 2 pi times the frequency times the time, right? And so that's helpful, and it's representation for voltage and current within an alternating current circuit. Okay, so now we're talking a little bit about power, and this is kind of where it's most important. These RMS values will come into play. Power equals current times voltage. So if power equals current times voltage, and current and voltage are both constantly fluctuating, that means power must also be fluctuating. And so the mathematical expression used to express this is power at a certain time equals max current times the max voltage times the sine squared of 2 pi times the frequency times the time. And we can look at a little graph of this as well that will help us kind of move forward. And that's, so you have power, and you have, if you want the maximum value for power, what you're going to do is power times current max times voltage max. But generally, you'd want to use the average. Okay, so one way of finding the average is 1/2 times both those maximums. And so this is where RMS values come into play. So RMS is just RMS values are just a calculated average of the voltage or current of an AC circuit. And so the power average can be calculated using the current RMS value and the voltage RMS value. And so current RMS equals I naught over the square root of 2. Voltage RMS equals voltage max or voltage naught over the square root of 2. And so when you set them to equal to each other, these two equations, we notice that they are in fact equivalent, because the square root of 2 times the square root of 2, right, it's just 2. So you have I naught times V naught over 2, which is the same thing as 1/2 times I naught times V naught. Okay, so it's standard practice to quote the P average, IRMS, and the voltage RMS values, just because it makes more sense to give these averages instead of giving a max or giving a min. And so these RMS values, we could say they're the equivalent DC values for a simple resistive circuit. So, and by this I mean, like in the case of a house that has 120 a household electricity of 120 volts when in alternating current, that just means that the voltage RMS value is 120 volts because this is the average. So it could have more and it could have less, but this is the average, and that's the easiest to share. And then in the case of a microwave, like in this case, it has a power of 1 kilowatt. So it consumes, the average power that it consumes would be 1 kilowatt. That's not the max, that's not the min, that's the average, because it's constantly changing, constantly fluctuating.
Alright, well, thanks everybody for watching. I just wanted to put up my resources if you needed any extra help. Thanks.